So I wonder what would you guys have done before we had Blackboard? Like when at the end of class, a teacher assigns an assignment.
Would rely on Blackboard to be just a list of assignments.
We'd either email it to you or we.
Oh, that's right. You could email it. I didn't get any emails. Not even from Charlie. Charlie. You're still crashing. All right. So is this guy not on? Oh, I got it on the wrong thing. Okay, so we should have, well, right now we have some bugs in here because we have RemoveFront, RemoveEnd, and these guys are supposed to return integers. So we're building this into our linked list. So we need to teach our linked list how to remove front and remove end. And then we need to update our interface. Now, last time I gave you the interface update to remove the view at bucket 0. That should get rid of it. The other one, we're going to have to figure out what that last index is. Actually, an interesting way of doing that might be this dot linked list container dot there a count get child count. So we might be able to do it just this way. Remove view at that guy -1. We can actually test that here real quick, see if we could just visually have it updated. So I'll have remove front and remove end return a void right now. So technically all they'll do for this exact second is they will update the interface, not actually update the linked list. And then we'll
have a print function in there so we know they're actually getting called.
well, actually probably to make sure the buttons work. It's a decent enough solution. Or decent enough suggestion. Because we're going to hook buttons up to these guys. Well, we're going to have buttons hooked up to functions that will call these guys, and we probably want to make sure that they are actually getting called. So right now our linked list, remove front and remove end, just updates the interface, doesn't actually update the linked list. We'll fix that in a few minutes. Let's go into our main activity now and add functions for those buttons that we're going to put in there. So we'll have a public void remove front button clicked, and this guy will call this .ll.remove front, and then we'll have another function public void remove end button clicked, this .ll.remove end. Okay, so now we need to go hook those up to our interface. So now these functions will do the right thing. Remove front calls remove front, remove end calls remove end. Go to our activity main. Let's throw a couple of more buttons in there. Why don't we just go ahead and put another row underneath that. So we'll go up here to our layouts. Here's our horizontal layout. I'm going to try to throw it underneath that guy. Big money. Did that do it? No. What did that do? It didn't even do anything. Why is this scrolling so much? All right. Why can't I get it to drop? Let's try it again. Let's try doing this. So I put that guy in the scroll view, and I'll try to bounce him up. It won't let me do it. Okay. So what I'm going to do then, since I'm having problems dragging and dropping it, this is one of those situations where we need to go into the text. I'll go down and grab my new linear layout that it put in there in the wrong place. I'll cut it, and we'll go ahead and place it before the scroll view. And the height of this guy is wrap content. So now we go back to design. We have another one of those dudes here now. Stretch that out a little bit. And we'll throw a couple of buttons in there. There's one button. It's supposed to be the other button. There we go. So this guy will be RemoveFront. This guy will be RemoveEnd. All right. And then we want to go ahead and have those guys call the right function. So we'll set the onClick for RemoveFront to call RemoveFront. OnClick for RemoveEnd. Call RemoveEnd. All right, so now we should be able to test this guy and see if it updates our interface appropriately, and then we'll go update the linked list. So those two match. And then we'll do the more difficult versions, which is remove that index. All right, so let's add a couple of things to our list. All right, so I have 3, 2, 1 on my list. RemoveFront should get rid of the 3. RemoveEnd should get rid of the 1. So there's our RemoveFront and our RemoveEnd. Now, looking back at our, so if I do RemoveEnd again, that guy goes away. So real quick, if I go back in the linked list and I look at how I removed end, there's going to be several different ways you can pull this off. What I did is, so what we might do is we might keep track of the count of our linked list. Are we already doing that? We're not. So what we could do is every single time we add something to the front or add something to the end, we might keep an internal count in our linked list where we say count plus plus and it becomes 1 higher than it used to be. Similarly, when we remove something, we need to make sure we decrement that count. Now, that would probably make some reasonable sense to do that. We'll probably do that here in a few minutes, but just so we get to go through the exercise of having to traverse our list to get to that end node, I'm not going to do that yet. So to update our interface, though, it just so happened that our linked list container, that vertical linear linked list, that guy, our vertical linear linked list, the vertical linear layout, rather, he can tell us how many children live inside him. So he can tell us about his child count. So when we had 3 text views in there, his child count would have been 3, indexed from 0. 0, 1, 2. Make sense? All right, so that's what I did here. I said, linked list container, tell me how many children you currently have. And I want to remove the last one, so remove the guy at index, your count minus 1. Make sense? So I used the linear layout itself to tell me how many text views we had put in there. One way of pulling this off.
Can we make a count like that, internal count?
We will.
And then we use that count to minus 1?
Yeah, absolutely. It would give you the same number. Yeah. So if you have 3 things in your linked list, the count of that linked list would be 3. The number of children in your container would also be 3 because we're having those guys match each other, right? Yeah, it's going to give you the same number.
Could the child count is the view group method?
Yeah, it's the number of things in that view group. Yeah. Okay, so now let's actually do the logic for removing front and removing end. So let's go ahead and draw some pictures. It was 300 or 200? I couldn't remember because the number of people didn't tell me about their homework, didn't turn it in. Well, you're the one who lied to me. Look me in the face and tell me you didn't lie to me. You gotta get those eyes open. Ay, ay, ay. See, students just don't care about education anymore. You did everything except commit the changes. Is that the truth? So you'll turn it in later on? You'll turn it in later on today? Actually, you can submit it right now. You can submit your link.
It's in my PC at home.
Well, you can go to GitHub on your computer and get your link.
It's not pushed.
Oh, you haven't even created the repository.
No, it's like I pulled the repository, the old one.
Yeah.
It's there in my PC, but it's not being pushed.
Right, but you're pushing back to that same repository, right? So can't you just give me the link to your repository?
Oh yeah.
Yeah, so you can
submit
submit the link, and then later on you'll actually push the.
Yeah, whenever I push it from home.
Yeah, but you could submit the link now. That way it won't show up as being late.
Oh, okay. Yeah.
You see what I'm saying?
Oh, yeah.
Yeah. That way it won't flag me when I'm grading it as being late.
Okay.
But I'm going to see a different solution for yours than I'm going to see for mine, right?
Might fix some bugs.
It's just as bad in here, Bob. Yeah, so I forgot to put my Blackboard Dropbox up last time. I gave the assignment at the end of class, right? Not one of them said a thing to me until we came to class today. Like, oh, well, we didn't have a place to do it, so we assumed we didn't have to do it.
You just have to give them all 100?
No, that's not what's going to happen.
This is like the elite.
That's why I was just saying, I asked them, is this 200 or 300? Because I just wasn't sure, because of the lack of student skills. Yeah, but at least she has an excuse that she's basically been in a coma for a week.
Yeah.
What do the rest of the people have? They have nothing. Move off and say he's like walking his dog or something. All right, so let's look at what it means to remove the first element of our list. Okay. Let's see, we actually currently have this guy a little bit off in terms of our picture. So head holds the value 300, which points to the front of the list right now. So if we want to remove the front of the list, what we ultimately want to do is we want this guy, we want his value to get returned because we'll return the integer associated with him. But we ultimately want head to get hooked up here. All right, and we want to completely disconnect our node so we don't have any extraneous node pointers out there. So the pointer count is appropriate. All right, so first thing we're going to do is we're going to create a second node. Maybe this guy is node to remove, something like that. And we'll have him point to the same place that head points to. Then we'll have head point to his own next node. And then we'll have node to remove. This next node gets set to null. Make sense? Those are the 3 steps in that order. So we're going to go ahead and create node to remove and set it equal to head. So we're removing front here. So we'll create a node. Node to remove is equal to this dot head. And we're actually only going to do any of this stuff if this dot head is not equal to null. As long as we have a list to remove something from, right? So we'll put all this junk inside of there. We're not wasting our time doing anything if we didn't actually have anything on our list. All right, so we'll go ahead and we'll put a, I'll make this guy return an int. Now, because RemoveFront returns an int, at the bottom here, we'll go ahead, yeah, we'll do it down here. I'm going to ultimately return node to remove.getPayload. That's what I'm ultimately going to return. But this function here, RemoveFront, requires me to return an int. And right now, I only conditionally return an int. Because I'm only doing any of this stuff if head is not equal to null. All right? So let's finish the logic in here, and then we'll look at a solution for that. So I made node to remove point to the same thing as head. Then I'll say this dot head is equal to this dot head dot get next node. So he points to his own next node. That's this move. Then we set node to removes next node equal to null. We disconnect that guy. Node to remove dot set next node to null. And that fully disconnects it. All right. Now, because we've done all of our pointer updates here, we can safely return the payload of node to remove. Okay. So that's what we do there. And I'll go ahead and get rid of that system.out thing there. Now, notice it's not happy here. It's saying missing return statement because it only conditionally returns an integer. And we've advertised that it must return an integer. So we got a couple of options here. Well, let's throw it out to the class first. I have to return an integer here. Or I need to have some sort of exception get thrown. Java makes me deal with this thing. Could I return a -1? What would be wrong with returning a -1? Why might that not be a great idea? I mean, it's certainly legal. We could certainly return a -1 and say, look, that's an integer, dude. Here. But why might that not be a good idea? Could the payload at the front of the list be a -1? So we might return a -1. Sometimes you might return a -1 when we're actually returning the payload. And then we're returning a -1 also when there's an error. Our payloads allow for the value to legitimately be -1. Therefore, -1 is not a safe value to return. Is there any safe integer we can return? Or can our payload literally be any integer? Well, I can't return null here. That's a primitive type.
Can we move that return statement out of the
Well, if you move it outside of the if, okay, before I paste it here, what's going to happen? So I paste that guy there. It's now never heard of node to remove. Because node to remove was defined inside the if, so its scope lived and died right here. So then you could say, well, why don't we then move this guy outside of the if, right? Now Java seems to be happy, but we have a logic error. Why might this be a problem? This will give us a runtime error sometimes. If head was null, we're setting node to remove to null. What's going to happen here when we ask a null value to get his payload? Bad news bears. We're asking nothingness to call one of his functions. Nothing has no functions. All right. Nothingness, yeah. Bad grammar, but meant the same thing. We're fine. All right, so can't do that. Java would have been happy with it until we ran into a runtime situation where we happened to try to remove something from the empty list. Then it would have crashed. So this is the correct logic when we don't have the empty list. Now, when we do have the empty list, though, we have to handle this situation. So what we can do, let's throw an else here. From an Android app perspective, we would probably give like a little pop-up saying that cannot remove from the empty list, or list is empty, something like that. Anybody remember how we give a pop-up like that? Toast, yeah. So we have a guy called toast.makeText, and this guy takes a context as well as the text, and it just so happens we have a context available to us. So this dot the context, then it wants the character sequence, so we're going to say list is empty, and then it wants a duration, and that's a number of seconds, I believe. So maybe have that pop up for what, 2 seconds? Fair enough. 2 seconds, then goes away. All right. What's up? Does it want to float?
No, you have to type in toast.long. There's toast long.
Oh, that's right. So these guys, this guy, toast.long, toast.short, even though they ultimately come out to integers. In fact, we probably could have put just a 0 or 1 there. Probably is happy. Interesting. That guy is an int, isn't he? That's interesting that they actually test against that. So toast.long, toast.short, those guys must be what kind of animals? Are they're fields, so they're variables. Are they class fields or instance fields? Class fields, how do you know? Calling it with the class name, which is called toast. So we'll make this toast.short. Okay, which is holding a constant. It showed it was a constant 0, but it didn't like me using the constant directly, so it's testing against making sure you actually pass it. This guy behind the scenes is probably what's called an enumerated type. So it's actually requiring a toast enumerated type to be passed to it instead of a normal integer. That's why it was screaming. Unimportant for us in the big scheme of things. So we either have long or short toasts, okay? Now this guy is going to pop up a little message letting the end user visually see that, okay, bad things happened. But what isn't going to happen? Notice that Java's still upset. I'm still not returning a value here. So I need to throw an exception. Remember exceptions? Now I can do a simple exception. I can say throws new runtime exception empty list. Something like that. Let's throw new runtime exception. Right, so I can do that guy, and that'll give me a little error. And notice now that Java's happy. It's saying, look, we understand that you've given yourself an error-prone out. Okay? But the side effect of this, so let's look at this guy right now for RemoveFront. So right now, RemoveFront does the visual thing it did before, right? But it also actually disconnects it from the linked list. So now we're ultimately getting our linked list updated as well. If we had the empty list, we're going to give a nice little pop-up on Android telling us that this was the empty list, just FYI. Not going to update the list at all. We're not going to update our interface at all. We're just, hey, empty list. But then we're going to throw this runtime exception, which is going to give us kind of an error message out at the console, but not actually crash our application. So let's see what that does. And then we're going to talk about why this might not be the best idea in the world. All right, so I'm actually not going to add anything to my list because right now this dot head is equal to null, correct? I'm going to go ahead and try to remove from front. If I try to remove from front, it's going to get into this else here, right? So I should get a toast and I should get a runtime exception. So, runtime exception does crash an Android app. Interesting. Okay. Well, let me show you the exception we got down here then. That's in logcat. Where's my exception? Oh, it didn't actually get my exception. Let me run this again in case something funky happened. Move front again. Make sure. Just for testing's sake, I'm going to return a -1 for a second here. Just want to make sure we're doing that toast right and it's not crashing on the toast. I'm not seeing the toast. Is it like a dot show after that? Yeah, I think we got to show the toast. There's our toast there at the bottom. List is empty, list is empty. Okay, so I'm not sure why it's not showing the exception out at logcat, but this isn't the way we'd want to do it anyways. Let me just try it one more time. That way we have the toast working just in case that was causing an issue, but I don't think it was. Yeah, this guy still crashes. All right, so assuming that didn't crash the app, it's the wrong thing for us to do anyways. The issue with this is out here inside of our main activity, when we call RemoveFront, our RemoveFront function returns an integer, correct? But we've decided that only situationally returns an integer. This line cannot finish unless it's actually returned an integer. So I would have to try to do this. And then catch a possible exception, E, and then I could choose not to do anything with that exception. Because this guy might not actually give me an integer. I might not have a real number to work with there. Because if it threw an exception, then I have to try to do that. Because it might throw an exception. So let's see if this will run through a runtime exception. Otherwise, we'll just create a regular exception. So there's my RemoveFront. Notice it's happy again. So now the advantage of a runtime exception like this, even though we're not getting any output out here, which was kind of weird to me. I wonder if Android just doesn't like runtime exceptions. Exceptions should still print out on its own. Yeah, when it raises an exception, it'll say, you know, whatever exception, and then red, and then we can, this is catching that actual exception. So we would technically, if we printed out E, like you're saying, like E.print stack trace or something, it would show the exception twice. We should see it in system.error in red, and then we would see it in how we wrote it out. It's possible that system.error doesn't show up out here. In fact, we can test that. System.err.println. Just do a blah. All right, so typically that would show up in red. No guarantee that that's how this terminal does that, but this is going through the error output stream, which usually in operating systems gets redirected to some log file. But typically if we're running a Java program from the command line, it shows up in red alongside with your normal stuff, so you know that, oh, there was an error. So let's run this again and see if we don't see blah, that means system error is going someplace else. Yeah, I don't see a blah. If we do system.out, we should see it. Where's my blah? I guess we can't use runtime exceptions. That's fine. So rather than a runtime exception, this is, if you're writing a normal Java application, this is kind of a quick and dirty way of getting out of a problem. It keeps you from having to do some extra stuff. So what I'm going to do is I'm going to return a new exception called empty list. Now, if I'm going to throw an exception, I need to advertise this guy as throws exception. And when I do that, now it's required that I try to call that function. Remember before when we just had that runtime exception? This guy didn't show up as an error. Now notice he's an error. If I highlight this, it's going to say unhandled exception. Because I've specifically advertised that that guy throws an exception, I now have required myself to put it inside of a try. Because now we're saying, look, this might not work. I might not be able to remove the front element because there might not be a front element. So I'm going to try to do it. And if this happens to work, then I can do stuff with that element, assuming you stored it somewhere. So, we have int value is equal to that. That's the element that was returned. Now we can choose to do something with that element if this didn't fail. If this did fail, then we can print something out here. We can say empty list or something like that. But by advertising that it throws an exception, we now make it required for us to try it rather than we should try it. Let's run this again. I expect this will work this time. Are you kidding me? Does it not go out to logcat?
Disconnected embedded. Disconnected.
Let's stop it officially and then restart it.
Right there.
Yeah, I stopped it. Let's reconnect it and let's see if it does some better stuff. Oh yeah, that's not updating at all.
Let's go to drop down arrow right there.
This guy? Oh, disconnected. Oh, that's the guy it's connected to. So we may have been getting exceptions all along, right? That's what you're saying. Wow, there's our empty list. So now let's, here, we'll just test it here for ERR. Run this again. Yeah, system error shows up out there. Interesting. Well, they ultimately do the same thing. The difference here was if we throw a runtime exception, we don't have to advertise that we are throwing an exception, but we saw that we still needed to handle it out here since it sometimes could be an exception. So now we've specifically said, look, we know this guy might not return an int. Therefore, it's probably appropriate for us to specifically advertise that this dude throws an exception. Make sense? So that means that we then have to wrap it in a try and then catch the exception that might happen and do something with it. Well, you don't actually have to do something with it, but you could do something with it if you wanted to. All right, so this guy now should work for removing front. And if actually we want to prove it, we can say this .ll.remove front. Sorry, that's not what we're doing. This .ll.display. So after it has successfully removed something from the front, we will display the linked list. That'll go out to the terminal. So let's run this again. And let's add a couple of things. So we'll add front, add end, whatever. We'll do remove front. This should now show us just the list too. Make sense? So we've successfully removed from the front now. All right, so now we need to go and we need to remove from the end, which means we need to traverse the list till we get to the very last node, right? So remove end is probably going to be something pretty similar. So let's say throws an exception. Now the advantage of us doing this here is by specifying that we're going to throw an exception, because we've decided, okay, will remove end always return an end? That's the question we're going to ask ourselves at first. And we're going to say, you know what? It won't, because if we're dealing with the empty list, it won't actually return an int. It's going to throw an exception. Therefore, why don't we go ahead and say that it's going to throw an exception here? That way we're policed on two levels. One level is we're going to have to throw an exception. The other level is out here. We'll have an error here which will remind us to put that in a try catch. Because if we don't specify that we're throwing an exception, even if we throw a runtime exception, we're not required to wrap this in a try catch, which might mean we've introduced now a potential runtime crash error into our program, all because we forgot to wrap this guy in a try catch. Make sense? So that's the advantage of right off the bat going ahead and officially advertising that we intend to throw an exception, because now we've reminded ourselves through an error message later that we need to patch up that other side to write it correctly. Okay, so remove end. This guy's ultimately going to be returning an int. We'll go ahead and ask a pretty similar question. We'll say if this dot head is equal to null. Actually, if it's not equal to null. If we're not dealing with the empty list, we will ultimately be updating our interface to show one less thing. But before we do that, we need to traverse the list to find the node right before the last node. So if we think about our picture here, let's go and just rehook this up. The node to remove, we're going to go and find that node to remove first. So we're going to start at the head. Does this guy have a next node? He does. Move there. Does this guy have a next node? Yes, he does. Move there. Does this guy have a next node? Yes, he does. Move there. Does this guy have a next node? No. So are we currently pointing at the node that we do want to remove? We are. So let's write that first. All right, so we're going to identify the guy we're ultimately going to remove. So we'll say node to remove is equal to this dot head. Now we know we're only in this if statement if head actually points to a real place. We might be dealing with the one list. That could be what we're dealing with. So we're going to go ahead and how do I write the logic for node to remove to ultimately point at the last node? How do I write this logic that starts node to remove off at head and keeps traversing the list until we finally get to a node whose next node is null?
Node to remove, not null.
So while node to remove, you want to say, well, that guy's not equal to null?
Yeah.
So while he's not equal to null,
Yeah.
okay? We're going to say almost on that. What do we? And what do you want to do with it?
And we'll have the node to remove set next node. I mean, node to remove equal node to remove get next node.
Okay. Node to remove is equal to node to remove dot get next node. All right, do you want to update this at all?
Yeah, that's get next node, right?
Yeah. So while node to remove has a next node, that's what that guy says, right? While his next node is not equal to null, go ahead and kick him down the list a little bit. Set him to his own next node. This is going to keep happening over and over and over again until we finally run into a node to remove whose next node is equal to null. That will cause this loop to fail, and when we dump out over here, we know that node to remove points to the very last node. Make sense? Okay. So now we have this situation. All right, now ultimately, I need a, if I'm going to disconnect this guy, I mean, I know that I now point to the guy I want to ultimately return. So I know I'm going to return node to remove.getPayload. That's the value I'm going to return. But I need to do some disconnecting first. So really what I'm going to need to do is I need to do that. So the question is how do I do that?
So somehow we're going to set the previous node, that previous node to null.
So now what we need to do is we need to find the node that points to next node. Or points to, I'm sorry, to find the node that points to node to remove. So we can create and we could do this all in one loop. I'm going to do it in two here. So we're going to find the node that points to node to remove. So we're going to go ahead and say prev node is equal to this dot head. Then while prev node dot get next node is not equal to node to remove, prev node is equal to prev node dot get next node. So we'll start prev node at the beginning of the list, and we'll keep kicking him down the list until we finally get to a node whose next node points to him. Now this has one little flaw in it. This does not handle the one list. If we had the one list here, so just pretend like this other stuff doesn't exist, and the last node in our list was this guy right here. So we have a list that has just a single node in it. Okay? So node to remove, we start off at head. We keep going as long as node to remove's next node is something. Well, I'm presuming our list actually looks like this right now. Okay? So now node to remove is in its proper final place, correct? All right. Well, now we're going to say, we're going to create another one of these dudes. So we're going to say prev node. We'll make him go to head. Now, if prev node currently, well, we'll ask the question. We ultimately want prev node to be the node right before node to remove. Correct? Well, if it's a one list, is there any way for us to get prev nodes next node being equal to node to remove? Because that's the question we're asking here. We're saying while prev nodes next node is not equal to node to remove.
It would just check first.
No, we can. We want to see the error first, though. So, is it true that prev nodes next node is not equal to node to return? Yeah, that's a true statement. They're not the same thing. So what are we going to do? We're going to set prev node equal to his own next node. So now prev node sits here. Very next question we ask is, while prev nodes get next node is not equal to node to remove. Prev nodes get next node. Well, prev node currently points to null. So we're going to get an error. So we tried to call get next node on nothingness. So we want to ask this question. If prev node points to node to remove, or we can ask the question, if node to remove and head are the same, then we know we're dealing with a one list, right? That's kind of our special case. So we can ask the question, if node to remove is equal to this dot head, we have a one list, right? And in a one list, we will not be able to find the previous node. It's not a thing that could happen. Else, we can find a previous node, so we'll go ahead and find that previous node. That make sense? So if we have a one list, we have a list that looks like this, we won't actually even create a prev node. Node to remove will point to the same thing head points to. So how do we remove this guy then? Ultimately, I want to disconnect head, right? So I'll say head, set your next node. I'm sorry, rather, head equals null. So we'll say this dot head is equal to null. That will disconnect head from node to remove. But we haven't lost node to remove yet, right? Because node to remove points to the thing we want to have. So we're going to ultimately then return node to remove dot get payload. That's the value we'll return if it's the one list. Otherwise, if we're dealing with something that's more than the one list, let's go here. Node to remove points to the very last guy. Head points to the very first guy. Then we created a new dude. This is prev node. Prev node is going to go start off at head and keep going until he runs into a node whose next node is node to remove. Is this guy's next node node to remove? Keep in mind, we know we only have a two list. Is this guy's next node node to remove? It's not, so we're going to kick him to his own next node. Is this guy's next node node to remove? He's not, so we'll kick him to his next node. Is this guy's next node node to remove? It is. So he's good, right? So that means when we come out of here, prev node points to the node right before node to remove. That's what we just did. All right, so our picture currently looks like this. So now what do we do? Well, we're going to set prev node's next node equal to null to disconnect it. So prev node set next node to null. So now this guy is disconnected. Then we can go ahead and return node to remove dot get payload. Now notice here that we have the exact same return statement in this if as we have in the else. So if you want to be a little bit more efficient here, we would take that out of there, put it after the if else. Because no matter what we do, if we do the stuff inside the if, or if we do the stuff inside the else, when all is said and done, we do want to return node to remove.getPayload. Make sense? That's going to happen regardless. Okay, now we're only doing all of this if head was not equal to null. If we have the empty list, we have nothing to remove. Otherwise, we're going to find the last node in the list. Then we're going to say, if it's a one list, just set head equal to null. Otherwise, figure out where the guy right before it is, and then disconnect him from node to remove. Then, ultimately, return the payload for node to remove. And then remove the view at that last position. The else here is we have an empty list. If we have an empty list, we're going to throw a new exception name it whatever you want, say empty list. And before we do that, we're going to do a toast, right? So toast dot make text this dot the context, and we'll say empty list, and we'll say toast dot short, and then dot show. All right, now notice right now, this guy's not happy because we have a return statement immediately before we remove something from our interface. Don't return until we're completely done. So I'm going to just steal this line, and we'll throw it right before the return. So we're going to update our visual interface and then return the actual integer. Okay? Otherwise, we'll say, hey, this is the empty list, can't remove anything. We'll go ahead and throw that exception. Then we reminded ourselves out here that, oh, this guy might not work. So we will try to do this. Then we will say this .ll.display, if it worked. We will then catch an exception E, and we don't have to do anything with it if we don't want. I'll just show you that version of it. So I'm going to try to do this stuff. If it works, great. That means something was actually removed. I have the value. If I want to do something with the value, perfect. Otherwise, I'm going to catch the exception and choose to do nothing. Just kind of pitch it. And nothing actually changed, right? Linked list didn't change, interface didn't change. It was as if we never clicked the button. All right, so let's run that guy. And we want to test it with our couple of different like kind of special conditions. So we want to certainly test it on the empty list. All right, so let's remove end on the empty list. Empty list, we're good there. Let's add, doesn't matter if we do add front or add end, so we have our one thing there. So now we want to remove it on the one list. That's a special case one. Worked. All right, and let me just go back in here because we are displaying our list, right? So we go back in here and I click on logcat. You'll see now our list is the empty list. So it officially got updated to now be the empty list. All right, so now let's add a couple of things back to our list. So we'll do a 1 and a 2. Let's try it on the 2 list. So this should remove the 1. And now notice we have a list that just starts with a 2. All right, let's put some more stuff in our list, more than the 2 lists. So we'll add 2 to the end. We'll add a 3 to the end. So now it's a 3 list. Remove end. There's the 3. Let's just make a lot longer list. Oh, I keep hitting remove. Like, why isn't this stuff getting added? I just wanted extra work. All right, so now obviously this is close to an infinite length list. So we'll do remove end on that guy, and we see that we can keep doing that until we get to the empty list. All right, that makes sense? So that is remove front and remove end. All right, questions about any of that?
If we don't try to catch the exception, that will crash the program.
Yeah, if you put yourself into the situation where you try to get the payload of something that doesn't have a payload, it'll crash. Because then what you have is you have an object, so like node to remove is null. And you're saying, dude, give me your payload. He's not even a thing. He doesn't have a function called payload, let alone a payload. And Java's going to have a very difficult time with that. Does that make sense? All right, so that's why in that situation, since we know there are a couple of special cases, we have to choose to take care of it. And kind of the lazy way around that is to use a runtime exception. Because a runtime exception, see, the issue here is that if we go into our linked list here, if you have a function that throws an exception, whoever calls this function is going to be forced to deal with that exception. So they'll either have to try catch it themselves, or they'll have to throw the exception themselves up to the next level, right? Past the buck, if you will. But any way you cut it, if you advertise that your function throws an exception, the next guy, the guy who calls this, has to take that into consideration. He will be forced to. He's policed. Make sense? If we decide to take the lazy route and say, oh, you know, I don't want to cause myself any additional headaches outside. I want this guy to be kind of self-contained. I can remove that thing for throws an exception. All right, so now, and it's not going to like this guy because, you know, it's we would have to make this a runtime exception. So a runtime exception does not require a throws clause. So since we made this guy a runtime exception, now, well, here, let me, we'll have to do this as to show you the crash. I'm going to go ahead and say, yeah, see, it won't crash in this case because value will have a default value. Well, I'll just say it out loud because I'll have to turn this into an object type in order to really show you the crash. But the issue here would be is that we may not actually have a value inside a value. Integers do get a default value, so it would be like a 0, even if it didn't return anything. But if this guy did throw an exception, we wouldn't necessarily get a value. Since it's a runtime exception, we are not required. I can move this guy outside of here. That's remove end. Am I working with remove? I'm working with remove front there. Go down to remove end. So I'll move this guy because it's this function that doesn't throw the exception anymore. So notice he's cool with this. Because I did not specifically advertise that I'm going to throw an exception, this guy is none the wiser. But he might not actually get a value for value because an exception might still happen. Make sense? We just haven't been forced to deal with it, which means that if we try to do something with this value, or we have assumed that our linked list has changed in some way, that might be a very poor assumption. And because we weren't forced to deal with it here, we may not realize there's that level of error checking inside the linked list. So good programming practice would say, if you have a function that might not operate the same way each time, that might not give you an official result, you should then advertise that that function throws an exception. And if you advertise that he throws an exception, then make sure you go ahead, and you can still throw a runtime exception if you want, but I'll just switch it back to an exception. Then you would go ahead and make sure you throw that exception. Even if it's a meaningless exception, it's all for the purpose of that other guy being able to call the try catch and then only situationally deal with the return value. Make sense? So most modern programming languages like Java, C#, Swift have facilities to deal with exceptions, which allow you to kind of gracefully handle runtime errors. In fact, sometimes it even allows the program to just keep going. Like in our case here, we were able to write a function that advertises it returns an integer, even though it might not always return an integer. Because sometimes the exception allows us to escape without actually having to return the integer, but it also has a facility to let the guy who called him know that, look, it didn't work. I know you pushed the button, but it didn't work for whatever reason, in this case, because you had an empty list or something like that. Make sense? Good.
So was there a way to solve this assignment without using this?
Oh, sure. So to remove front and remove end, I mean, you would just either, you could just say, we'll never try to remove something from the empty list, right? Or you can say, well, I'm just going to pick, like for instance, at the beginning we said, well, could you just return a -1, kind of taking that index of type of approach, return a -1 and just hope that wasn't the value we're going to return. You could do that. You could choose to pick just kind of a really strange number that you just hope is very rare. like, what are the chances? You got a 1 in 4 billion shot, right? Because you got 4 billion numbers to choose from. Integers are -2 billion to +2 billion. It's actually 2.1 billion. So you have 4.2 billion numbers to choose from. Just pick a really extraneous one. Just hope. Cross your fingers that guy will never be a payload. So those are less complete accurate ways. But the important thing for the assignment is get to the front of the list, get to the end of the list, and disconnect stuff from there. Something like that. So yeah, I mean, you certainly wouldn't lose points if you didn't do the exception. This is just more of a complete solution. Where for us, the mechanics of traversing the list are the more important aspects. All right, other questions? All right, so let me go ahead and commit this. So this is homework 3 solution. Commit and push.
If we try to fork your repository, is all that change going to be on there still?
Yeah, so if you, it's a good question.
I don't when I was trying to do it yesterday, it wasn't showing up.
Because it might say since you've already forked it, it won't let you fork it again. I think you could do a pull, but this is what I would probably do just to keep the assignment separate. I would go and I would rename your repository like homework 2 solution or something like that. Then now you don't have a name. Now you can go and fork it and get a brand new repository that starts from my starting point. So you can go onto GitHub and I think you can rename a repository on there. That way you could just keep having new starting points but still preserve the old thing rather than having to go back and look at the various things. You can also do a pull request, which will allow you to bring your existing repository up to date with the guy it was forked from. I think that's a button on there too. So either one of those should work. It just depends on how you want to keep track of your stuff, if you want to have them in separate repositories. All right, so for our next homework assignment, which I will certainly put up in just a moment, we want to have the ability to remove at a specific index. So for instance, if I want to remove, let me just clean this up a little bit. If I want to remove from 0, that's a RemoveFront. If I want to remove from, let's see, 1, 2, 3. If I want to remove bucket 3, that's a RemoveEnd. But what if I were to remove bucket 1 or bucket 2? So RemoveAddIndex should check to see, well, if you're removing from bucket 0, we might as well just call it RemoveFront, right? But if I want to remove from bucket 1, I want to remove this guy. Now you have to be very careful. This is more difficult because now you gotta surgically extract this guy and make sure that these things get rehooked up. Make sense? So for your next homework assignment, add a button as well as probably another edit text because you're going to have to be able to give it the index that you want to remove and have it successfully remove that element for the list and update your interface. So now that remove an index for your interface is going to come in pretty handy, right? Remove view and index. It's going to make that part of it pretty easy because it happens to take an exact index. All right. I got to think about this for a second. So remove an index just does that. So then you can use the edit text though. So you also want to be able to add an index. Both of those, basically the same function. Add and remove an index because you have the weekend to work on it. Add and remove an index. Make sense? So you'll need an extra edit text to type in your index, and then 2 more buttons: add an index, remove an index. That you already have that text box for it. Yeah, you have the text box already for the payload you're adding. You'll just need one additional piece of information to put it at a specific spot. All right. 2 new buttons, one for add an index, one for remove an index, and 1 new edit text for the index. You already have the edit text for the value you're adding. Cool? All right, I will see everybody on Tuesday, and I will get that assignment posted this moment.